Welcome to online coaching for the third year students. Now today I am going to discuss about the second part of numerical differentiation. In the first session we have discussed about the numerical differentiation, particularly if the required derivative for the set of values lies in the beginning of table. In the table, the given set of values, the required derivative lies at the beginning. Suppose if the question find y dash of 1 and y double dash of 1. Now to observe that 1 lies at the beginning of table. So to make use of the previous method what I explained in detail in the previous session. Today I am going to discuss similarly about the differentiation if the required derivative lies at the end of the table. Suppose find f dash of 5 and f double dash of 5. The questions are like that. Now to notice that the required derivative 5 f dash of 5 and f double dash of 5 lies at the end of the table in the given set of values. So we have to find out the numerical differentiation by means of the two formulae. Those two formulae are derived by the Newton-Gregory backward integration formula. Now for that, see one by step by step. First the values of x 1, 2, 3, 4, 5 and the values of y 1, 8, 27, 64, 25 are given. These are given set of values. Suppose if they are not given, we can obtain this values by the given function. The second one. Okay. If the set of values are given, then for the given set of values, frame the forward difference table like this way. Formation of forward difference table for the given set of values. For the given set of values, x values are 1, 2, 3, 4, 5. Y values are 1, 8, 27, 64 and 125. First forward differences are obtained by taking the differences of 8 minus 1, 7, 27 minus 8, 19, 64 minus 27, 37, 125 minus 64 is 61. These are the first forward differences. Similarly, to find out the second forward differences, those are the obtained by differences of the difference of the first forward differences. 19 minus 7, 12, 37 minus 19, 18, 61 minus 37, 24. Similarly, third forward differences, these are the differences obtained by the differences of the second forward differences. That means 18 minus 12, 6, 24 minus 18, 6 and fourth forward difference of 0. So like this way, we have to construct the forward difference table in order to find out the derivative lies at the beginning or at the end of the table. Now to find the f dash of 5 first, f dash of 5, write the corresponding formula. Dy by dx is equal to xn. That means xn is the last argument. Xn equal to 5, 1 by h into nabla yn plus 1 by 2 nabla square yn plus 1 by 3 nabla cube yn plus 1 by 4 nabla power 4 yn plus and so on. I told again, this is the formula derived by the Newton-Gregory backward integration formula. Now here in this case, in this example, try to remember this formula like this way. Very simple. 1 by h nabla yn plus 1 by 2 nabla square yn plus 1 by 3 nabla power cube yn plus 1 by 4 nabla power 4 yn, etc. Now substitute the corresponding values from the difference table in the formula. 1 by h, the value of h is 1 because the difference between the consecutive values of the arguments is 1. Nabla yn is nabla yn is 61, first backward difference, plus 1 by 2 into nabla square yn is second backward difference is 24, plus 1 by 3 into third backward difference is 6. So next is 0. Leave it. Then after simplifying this step, we get the value 61 plus 12 plus 2 which is equal to 75. That means the value of dy by dx is equal to 75. First derivative value is 75 by the numerical method. Now you can verify what we obtained in the calculus method. With the calculus method, we obtained same value dy by dx is equal to 75. This is the differentiation obtained by the calculus method. This is also first derivative obtained by the numerical method. Both are same. Like this, we can find out the first derivative by the numerical method. Next, let us find out the answer for the second question, f double dash of 5. To find second derivative at the point x equal to 5, again you have to remember the formula for second derivative. D square by d square x equal to xn equal to 1 by x square into nabla square of n plus nabla cube n plus 11 by 12 nabla power 4 n plus 5 by 6 nabla power 5 n and so on. Again, this is also a formula obtained or derived by the Newton-Gregory backward integration formula. Now in this example, try to remember this formula. It's very easy to remember formula. 1 by x square into nabla square n plus nabla cube n plus 11 by 12 nabla power 4 n plus 5 by 6 nabla power 5 n and so on. Here, substitute the corresponding values from the difference table in this formula. 1 by h is 1, nabla square of n is the second backward difference is 24, plus nabla cube third backward difference is 6, and fourth backward difference is 0. So get 0. Therefore, substituting all the values, simplifying gives 30. So this is the value of this could be x plus x equal to 5 is 30. This is the value obtained by the numerical method. Second order differentiation at x equal to 5 equal to 30 obtained by the numerical method. We verified that the same value obtained by the calculus method. This could be square equal to 30 by the calculus method, and this could be square equal to 30 by the numerical method. Hence, we get the numerical differentiation by means of the numerical method. So this is the very simple example what I have taken to understand what is numerical differentiation by the simple and very simple example. We have to apply the same method, we have to adopt the same method for any given number of examples. For any example, it may be a lengthy example or simple example, any problems are given, you have to observe these points. First, observe that whether the given required derivative lies at the beginning of table or at the end of table. To find out the first derivative and second derivative, if it lies at the beginning or at the end, first we have to consider the difference table. Consider the forward difference table and write the corresponding formulae. If it lies at the beginning of formula, write the corresponding to formulae. If it lies at the end of table, write the corresponding to formula like this, and substitute corresponding values. After simplifying, we get the answer. Those are the numerical differentiation values. Thank you.